AirForce is a Blender-based software tool that allows users to create animated physical structures. Structures can be larger than those produced using the prior art and can actuate larger loads. Traditionally, animatronic structures were built using pneumatic actuators that were separate from the structural elements. The key idea behind AirForce is not just to replace the static structure with tubes, but to replace the actuators as well. This allows AirForce to create entire animated structures by folding up a single long tube. The resulting hubless single tube design allows for efficient single-person assembly, as the structure can be assembled on the ground. It allows unfolding and refolding design into a different actuated structure with 100% material reuse, easy transport and setup in the deflated state, and it offers excellent power-to-weight ratio, capable of lifting human weight. We started our design iteration towards lifting human weight with traditional single-tube materials, but then tripled the tube's cross-section. Next, we replaced the traditional fin seals with lap seals. This allowed us to increase tube pressure by a factor of 4. Finally, we replaced compressors with custom blowers, which allowed us to produce 50 times higher airflow. Combined, these 3 modifications allow us to animate structures under load. The dinosaur model, shown earlier, offers 3 degrees of freedom. Each of them has slightly different requirements. The dinosaur's jaws perform large movements and need to move at a reasonable speed. We achieve this by creating a variation of O'Neill's buckling actuator, the 2 ends of which we integrate into the single tube. Telescoping actuators are slow, but by extending linearly, this novel type of actuator produces sufficient force to lift or tilt the 60-kilogram dinosaur as a whole. To raise the dinosaur's tail finally, its backbone has to contract. Creating an integrated variant of Greer's muscle actuator, AirForce subdivides the backbone into several compartments. When inflated, the backbone gets wider, but contracts in terms of length. In combination, we found unbuckling actuators, telescoping actuators, and muscle actuators to cover the requirements of large animatronic structures. For a democratized approach, AirForce uses no custom machinery, but instead allows users to create structures manually from pre-made tube, Velcro ties, custom blowers, and custom inlets. Using the AirForce Blender plugin, users typically start by modeling a static version of their model. During modeling, AirForce reroutes the single tube through the model's truss structure in real time. At any time, users may convert selected segments into the respective types of actuators. When users click Export, AirForce subdivides the model to make it fit the user's tube material. Here the user uses 50-meter rolls, therefore AirForce subdivides the model into 5 50-meter subassemblies. As part of the export, here the dinosaur's head, AirForce generates assembly instructions in the form of stickers. The distance information on each sticker tells users how to space out stickers along the tube. Users then partition the tube at the stickers using Velcro ties, leaving 4-inch openings to permit airflow. To attach blowers, users cut a slit into the top layer of the tube using a kiss-cut knife. Insert a custom inlet and attach it using the inlet's adhesive coating. Users insert a blower and secure it. The stickers left and right of blowers are marked with the word seal. Here users create airtight nodes by looping the tube through the Velcro tie. Finally, users insert one inlet and blower into a segment without seals. This allows the blower to inflate the entire rest of the structure. Now users tie up the 3-dimensional structure by attaching nodes featuring the same identifier. Printed assembly instructions generated by the AirForce plugin provide clarity where needed. Tying the finished subassembly to adjacent subassemblies completes the model.